Okay, so now we're going to do some example problems from section 2.7. So, sketch a graph of the rational function by hand. Check for intercepts, vertical asymptotes, horizontal asymptotes, and holes. So, first off, this is the same as saying negative 3x plus 1 over negative x plus 1. So when I'm looking for the zeros, which I'm knowing that that's going to be when that's equal to 0 or 1/3. I also know that when I'm looking for the vertical asymptotes, I know that that's going to be when x equals 1. And I'm also going to look at this, I'm going to go, oh, hey, look, these are both the same degree. Negative 3 over negative 1 is a positive 3, so the horizontal asymptote is at y equals 3. And last but not least, I'm going to get the y-intercept. I don't need to worry about the end behavior because I know that it's going to be 3 because of the horizontal asymptote. By plugging in 0, which all means all this goes away, and that means y equals 1. So then what I can do is I can plot all those points and break the graph into regions. So 0 at x equals 1/3. So that means at 1/3, the thing's equal to 0. At y equals 1, which is right up here, let's say, it's going to be, it's this y-intercept, right? Horizontal asymptote's at 3, which means it's kind of headed this way, long haul, right? And vertical asymptote at 1. So it's got a vertical asymptote at x equals 1, right around here, and which means it's got a line that's never going to cross, okay? Just like that. Okay, believe it or not, this is enough information. So to fill out my graph, I know that's got to tend towards here, and it's going to either approach this way or this way. Now I know it must be this way because it never crosses the axis. Here it's got to cross here and tend towards that, and at the same time approach here. Now it can't bounce off or something like that, so it means that we're going to go through here, here, and then it's like that. And that would be our sketch. And you can go ahead and check this by using Desmos. Same here. We're going to find all the same information out and see what's going on. When is x equal to 0? When x equals 0. Hopefully you recognize that this is the same as x plus 3, x minus 3. Factoring is going to be your friend. So this has 2 vertical asymptotes. Long-term behavior, x over x squared. This is higher power, so it has a horizontal asymptote at y equals 0. Y-intercept. Well, when you plug 0 in, 0 squared minus 9 is negative 9, but 0 over anything is 0. So the y-intercept is equal to 0. But it also has a 0 at 0, so that doesn't tell us a whole lot. It's kind of unfortunate, right? But we definitely know that 0 is a point on the graph. We also know that there's vertical asymptotes at 3 and negative 3. So say that looks like 3. Whoops. Let me use my vertical asymptote line. Vertical asymptote, vertical asymptote. I'm going to go ahead and label those. That's negative 3, and that is 3. Okay, so here's where the fun really begins. What does this look like? So the long-term behavior is 0, so we just don't know what's going on. So we're going to have to test points through all of these. Because here's the problem. This, because it's going to cross through, it has a multiplicity 1, right? Is either going to go up from left to right, or it's going to go down from left to right. So we need to pick a point to test. And then outside, we don't know if this is above or below. So we're also going to pick a point. All right. So let's go ahead and start doing that. That means what I'm going to do is just test sign. So I'm going to plug x equals negative 4 in. And when I do that, I get a negative over, now negative 4 is 16 minus 9 over positive. So it's going to be negative, right? It's not negative, which means it's going to be down here. So it's going to be approaching here and coming down like that. So I plug negative 4 in. Heck, let's plug x equals 4 in. Let's see what happens. Now hopefully you recognize that when I plug x equals 4 in, because that's positive over 16 minus 9 is still positive, it's going to be positive, so it's going to go like that. Now let's plug x equals 1 in. Because 1 is over here, so I know if it's positive, it'll be going up like this. I know if it's negative, it'll be going down like that. So I plug x equals 1 in, I get positive over 1 squared minus 9. That's 1 minus 9 is negative. So the net is going to be negative at that point. So at 1, it's going to be below the axis. So I know it's going to be up here, coming down like that. Get good at testing points is my advice, but all you're worried about are the signs. Okay, sketch yet another graph. So can we factor the denominator? Yes, we can, just like Bob the Builder. This would be a +4 and a -3, which means these zeros are at, well, there are none. Why? Because it has this factor in common, which means that's a removal discontinuity. Now, it does have a vertical asymptote at x equals 3. Removal discontinuity, like I said, at x equals -4. That's not going to be very special in the graph. And actually, let's see, what does the long-term behavior? In other words, what's the horizontal asymptote? Well, when I look at this, I see an x, 5x specifically, over x squared. So the denominator is larger, so it's going to be y equals 0. And maybe the y-intercept will get us something. If I plug 0 in, that's 5 times 4, or 20. Over, if I plug 0 in, everything else goes away, -12, which is negative, what is that, 10/6 or 5/3, right? So what happens? We have a vertical asymptote at 3, so let's just call that 3, right? It's 3 right there. We have removal discontinuity at -4. Hold on that. We have no zeros, unfortunate. Horizontal asymptote, it's approaching 0 on each side. And a y-intercept of -5/3. Bummer. So -5/3, that's like right there, right? And we know that that's a point on the graph. Okay. Do we have enough information, Houston? Why, yes, we do. As a matter of fact, this is all we need. We know it never touches the axis, so it's got to be in this negative region here for this part of the graph. Like this, right? Now, the only thing we don't know is it's still negative here or is it positive? So what do? We test a point. Let's say x equals 4, right? So we plugged 4 in there. 5 times 4 plus 4, well, that's going to be positive in the numerator. 16 plus 4 is 20, minus 12 is positive, so it's going to be positive net, which means it's going to be above the axis, so it's going to approach infinity here and head towards 0 that way. That wasn't too terrible, actually. Now, the only thing I have not accounted for is the removal of this continuity at -4, which is, let's call -4 right here, shall we? -4. So what do? I make a hole in the graph, because that's how removal of this continuities show up. They're just kind of on the stealth, if you will. All right. Use the graphing utility to graph the function. It determines domain identifying vertical, horizontal asymptotes. Well, I'm just going to go ahead and boldly just go ahead and factor this and hope, right? What times what is -6, but adds together to get a 3. Well, how about -2 and +3? -6, sure enough, adds to 1. So I know this has a 0 at x equals -4. Vertical asymptotes at x equals -3 and x equals +2. Horizontal asymptote, y equals 0. How do I know? X over x squared. Y-intercept is y equal to 4 over -6 or -2/3. So, knowing this, they don't actually ask you to sketch it, so I'm just going to do it anyway. I got an asymptotes of 2 and -3. I know it's got a y-intercept at -2/3. I know it's got a 0 at -4. Right? I know the long-term behavior is 0. Okay, so what does this mean? Well, it means I know what's going on in the center portion. I'm not sure about this, and I'm not sure about this. I know it's tending towards 0. So what I'm going to have to do is test some points. So I'm going to plug -5 in, right? So I'm going to say x equals -5. Plug that in. -5 plus 4 is negative over -5 squared, so it's 25. Plus a -5, so that's 20. Minus 6, that's positive. So in the end, it is negative. So at -5, it is negative, which means it must have started up here and then crosses and comes up like that and levels off at 0, right? It doesn't actually hit the axis. Key thing at -5, it's negative. Here, it's got to hit this point, but never cross the axis. So it's got to start down here, come up and go back down. Now here, I don't know. So I'm going to plug in x equals 3 and see what happens. 3 plus 4 is positive. 3 squared is 9, plus 3 is 12, minus 6 is still positive. So it's positive, which means it's all above the axis at 3, which means it's going to come down here and exhibit that sort of asymptotic behavior. So domain, vertical and horizontal asymptotes already did. Domain is, well, the domain here is where it's not, which is at -3 and -2. So unfortunately, it means negative infinity up to, but not including -3, and from -3 to -2, non-inclusive, and from 2 to infinity. That's it. Okay, rational function with a slant asymptote. Oh no, sketch a graph of the rational function. So we know that this has a 0 at x equals 0. This graphs out as x, or factors as x plus 1, x minus 1, right? Which means it's got vertical asymptotes at x equals 1 and x equals -1. Now, they tell us it has a slant asymptote, x cubed over x squared. So what I need to do is write this out and do synthetic division. Now here's the problem, +1 and -1, right? So what I need to do is divide these. Now, instead of doing polynomial division, which I do not feel like doing, I'm going to first divide by 1 and then -1 and see what my result is, okay? Please note, x cubed plus 0x squared plus 0x plus 0. So I bring the 1 down. 1 times 1 is 1. 0 plus 1 is 1. 1. 1 times 1 is 1. Remainder, that. Uh-oh. Here's a problem. That's not actually a root. So we are going to have to resort to polynomial division to get our result. Sorry. Now we don't have to worry about the remainder, which is kind of handy. Okay. So x squared plus 0x minus 1, and then x cubed plus 0x squared plus 0x plus 0. Okay. X squared times what is x cubed? X. So then when I multiply that out, x cubed plus 0x squared minus 1x, or minus x. Then I subtract. Bye. 0 minus x is 0 minus a negative x is just x plus 0. Can I ever get x squared to equal x? No. So there is no term, it's just remainder at this point. So what does that mean? The oblique asymptote is y equals x. Okay. So I know that this has vertical asymptotes here and here. It's got a 0 here, right? I know that that is at 1 and that is at -1. So then what is happening? Well, I know that the graph over the long haul is heading off this way and this way, which means if it's never crossing the axis, it's going to go kind of this and then asymptotically there. Here, same idea, like that. Here I need to test a point. Unfortunately, I can only test a point like 0.5. Now this is where the fun really begins. If I test x equals 0.5, what is 0.5 cubed? Well, it's positive, so it's positive. What is 0.5 squared? It's half of a half is a quarter minus 1. Well, that's negative, so it's going to be negative, which means it's going to be, so 0.5, it's negative, so it's down here. What's it going to be at -0.5? Well, it's going to be negative over negatives. So it turns out that we're looking at just like that for the sketch. And that concludes our examples of sketching graph rational functions.